All right, and now that we've gone over why you should use Docker, because it's awesome, and how to go about finding Docker images that you can modify, we are actually going to get started building. So what we're going to build today is just a really simple Python Docker container that has the packages that we want installed. And we're going to head right on over here and get started. I am using the PyCharm editor for all of this. If you're not using it, it's really, really great. Later on, I'm going to show you exactly like how you can set up your editor so that it integrates really nicely with Docker and you can do everything in one place. Including debugging, running commands, everything. You can do it in one place, but right now I don't want to get distracted by that. I just want to show you how we would go about building an image. So again, like I said previously, I'm going to use the Mini Conda 3 image. So Mini Conda is a bit of a scaled down version of Anaconda, which is the scientific distribution of Python. If you're not familiar with it, it's really, really great. It makes installing things like so much easier, especially scientific software. There are a ton of groups that contribute software to Conda and to make the infrastructure really, really nice. So I guess I could have a whole nother video on like why you should use Conda because it's awesome. But just take my word for it. It's great, use it. So now that we have this, I'm going to show you how to build the image. So whenever we're going to build a Docker image, the very first requirement is that we have a Dockerfile, and in that Dockerfile, we define our base image. So in this case, this is from Continuum.io Mini Conda, and then this is a version tag. So you always want to pin your exact versions. Sometimes I get a little bit lazy and I don't pin the tag. And I always, always, always regret it because at some point something gets updated or something gets changed and everything that I ever did breaks. So listen, save yourself the pain, pin your versions, okay? Just do it. Once we have that, the very first thing that I'm gonna do is I am going to say, this is from the Debian version, so it's using apt-get. So apt-get update, apt-get upgrade, install, and then I also like to have Vim and SSH installed. I just find, I end up using them a lot, especially Vim. So if you don't care about having these things, you can modify this. You can just take this right off, see? Done, all gone. I want it, so I'm gonna keep it. And then once we have there, I always save my environments, which is the Python and R and Perl and Ruby and whatever packages that I want in a conda-env configuration file. I am going to show you that in a few minutes. So we are going to copy, which is relative to the project root. It's right here in this directory. You can see it. It's right here. From the relative in my project directory to my current working directory inside the container, which in this case is /root. You might have to do a bit of detective work to figure this out, and I'm going to show you how to do that later, but for the Mini Conda image, you can just know that it's /root, and you don't have to worry about it so much anyways. Once we have that, so once we've copied this file from our host system to our current working directory, we are going to run conda-env create. We can run conda, it's already installed, because we're using the base Mini Conda 3 image. If you were just using an Ubuntu image, obviously you would have to do that yourself, and this is really like the value of going and just looking for pre-built images. It's really, really great. This is just a bash alias that I like to have. If you don't like it, just get rid of it, it's fine. And then this is the Conda magic. So if you've used Conda before, you'll know that they do source activate. I think now, actually, in the newer versions, it's Conda activate. I'm a bit of like a dinosaur about updating my versions. So source activate Python app. Now, when you're running things in Docker, running like shell aliases it can be like a bit tricky. And just to be safe, what you'll want to do is you'll actually want to make sure that you know the environmental variables that are being set. So for instance, if you dropped into a shell, which I'm going to show you how to do later, in your Docker container, you would have this Python application. It would just be there immediately. But there are other instances where like that source activate wouldn't run. And so you just want to make sure that you also have everything set as environmental variables. If you've never like kind of gone into the magic of what happens here, what it's doing is it's setting environmental variables for you. That's it. That's all that it's doing. So I've already figured out what these are. It's conda.exe, conda prefix, conda python exe, so on and so forth. If you've never done this before, one really I don't know why my editor keeps doing this. Okay. One really helpful thing is you can run env, like env, it's a bash command, and that is just going to spit out all of your environmental variables. Just throw those on over to a text file, run your source activate, conda activate, module load, pip env, whatever, then run env again and look at the after activate, and then you might be able to just do a diff on these. You might have to like investigate it a little bit more, but from there you can very easily see what environmental variables are being set. I see this trips people up a lot, so I just wanted to go into that quickly and explain it. So we have this, we have our Dockerfile, we have our environment set up, and that's it. We are good to go. So what we're gonna do is I'm gonna bring up my terminal. Oh, actually, I'm gonna go back to the README for a second. So again, the project layout, I have my conda environment definition, I have my Dockerfile, they sit in the same directory because that keeps things nice and easy for me. And then once we have that, we are going to build this. So it's pretty easy. It's Docker. All the Docker commands start off with Docker. Then there's some kind of sub command. In this case, it's Docker build, and then -t is our way of giving a human readable name. Of course, underneath the hood, you get some kind of like long, crazy string with IDs and things, with like strings and numbers. It will look like this: successfully built, and then you get this big long string, which is a unique identifier for Docker. We don't ever want to have to remember that, especially not me, because I have like this really terrible memory. So I'm just gonna say Docker build -t numpy python, which gives us a nice human readable name that we can look at. So I actually built this already so that it wouldn't take forever, but I'm just going to show you Docker build -t numpy python dot. Okay, and you can see this builds really, really fast because I've already built it. Docker does this really handy thing where it uses layers. So like every portion of this Docker file over here, every portion of this Docker file is run basically in its own layer. Each one of these layers gets cached. So then if you like needed to change something down here, if you wanted to add something, it wouldn't have to completely rebuild everything. It could use all of its cache layers and build very, very quickly, which is very nice, of course. So once we have that, you can see that in action because I actually already built this image. So I built it up here. You can see, I don't even think I'm going to be able to go all the way up. Okay, but you know what, like whatever. So you can see, like this is the part where it's doing the apt-get or apt-get install. And then you can keep going. And then what do we have here? Yeah, still going. Okay, and then this is the part that's interesting for us anyways. We copy the environment file. We are going to do run conda env create, and then you can actually you can even see a bit of colored output, which is pretty cool. So, conda's telling me like, hey, a new version exists, go use it. I don't care so much. It'll be fine. I'm a dinosaur. I'll update eventually. And then it shows you, okay, all the packages that we are getting installed. And then you get this nice little thing here, source activate Python app. This is exactly what it looks like when you install it to your computer, because Docker is basically a computer. It's a virtualized computer. But, that's it. And then it runs all the other things. And then I'll show you what it looks like when it's actually building it. Then it goes, and then here it is, and it's all done. I know that it completed successfully. Otherwise, you would get some kind of like error message at the end. And then when I go and build it again, you get these messages that say using cache, and it just has the ID of the cache. So So then that's great. This built super fast. Just to demonstrate that again. Okay, there we go. I mean, you see how quickly that builds because the whole thing was already built and it's already cached. Even if I needed to play around some more with the environmental variables or anything, that's fine. It's going to be really, really fast. All right, so that covers at least an introduction of how we go about building Docker images. Of course, there is more depending on the kind of application and its complexity. But just to get started, this is what you need. You need a Dockerfile. You need a base image, and then you need to start installing whatever it is that you need. So, and then for this one, because this one is an application, I also need the packages that I need for that application. So that's it. I will see you in the next video where we actually take this container and we use it, we run interactive commands, we run shell commands, we run it as a command line application, we do all the things. Great, thanks, bye.